In the IT world, we use a lot of decimal prefixes. For example, when I'm talking about my CPU, I talk about a 3.2 gigahertz CPU. If I'm talking about the capacity of my hard drive, we use the word terabytes to talk about its capacity. So what I want to do in this episode is discuss what these terms mean and talk about a little bit of an issue. So let's start off with talking about decimal prefixes. We're going to start with a kilo. A kilo, shown with the letter K, is equal to 1,000. A mega, shown with the letter M, is equal to a million. That's 1,000 Ks. A giga, we use the letter G, is a billion, and that's 1,000 Ms. A tera, with the T, that's a trillion, that's 1,000 gigas. Yep, it keeps going. A peta, with the letter P, that's a quadrillion, woo! And that is 1,000 teras. And the last one that I'm interested in is an exa, which we show with the letter E. That is 1 quintillion, and that is 1,000 petas. Now, we've been using these decimal equivalents for a long time in the computing world, but I got to tell you something. Technically, they're not accurate, and I'll explain why. You see, in the computing world, we often use binary values. So if I've got, let's just start with something simple. Let's say I've got a 4-bit addressing system, all right? So if I have 4 bits, those bits can be all off, all zeros, or they can be all on, all ones, or they can be a bunch of different combinations of on and off. In that case, to figure out the number of combinations, we take 2, and then we take it to the power of the number of digits. So in that case, 2 to the 4th power, or 16. Now, in the computing world, we use big long strings of ones and zeros, so 4 isn't good enough. So when we're talking about big binary values, we break it up in groups of 10. So example, 2 to the 10th power, 2 to the 20th power, 2 to the 30th power. And to do this, we actually come up with a different kind of value. Now, these values, known as IEC binary prefixes, are similar to the SI prefixes we just talked about, but they're a little bit different. Let's start by going through the IEC binary prefixes. The best place to start with IEC binary prefixes is the KIBI, or KI. That's 2 to the 10th power, or 1,024. Next is the MEBI, or MI. That's 2 to the 20th power. GIBI, GI, is 2 to the 30th power. We're having fun. Let's keep going. TEBI at TI, 2 to the 40th power. PEBI at PI, 2 to the 50th power. And if you ever get this high, you can go all the way to XB, and that is 2 to the 60th power. The problem we have here is that these binary prefixes weren't even really thought about until the mid-1990s. So for decades in the computing world, we've been using decimal prefixes when what we really needed were binary prefixes. When we've been talking about our systems, we've been using prefixes like mega and giga when we really should have been using prefixes like MEBI and GIBI. The nice part about this problem is that these values are very, very close together. Let me show you what I mean. We know that a kilo is exactly 1,000, but a kibi is 1,024. They're almost the same number. A mega is 1 million, but a mebi is 1,048,576. They're almost the same number. A giga is 1 billion, but a gibi is 1,073,741,824. They're almost the same number. And that's where the problem came into play. Because we didn't have IEC values through most of the world of computing, well, we cheated a little bit. When we meant to say 1 mebi, because there wasn't a mebi yet, we said 1 mega. The bottom line is that there's a lot of confusion on these terms. And in fact, anybody who uses IEC binary prefixes is, well, I'm going to tease you when you walk away, all right? You're technically correct, but you have no friends. So for both the exam and in the real world, be comfortable interchanging these terms. When somebody says mega, they might be meaning mebi, and if someone says giga, they might be meaning gibi. So keep that in mind. You're going to see it on the A+.